Let's go ahead and solve for x. 1.1.1, we have x squared plus x minus 12 being equals to 0. Which two numbers do we multiply and get minus 12? And when we add them, we get plus 1, the coefficient of x. That is minus 3 and plus 4. So we're going to have x minus 3 multiplied by x plus 4 being equals to 0. X is equals to 3 or x is equals to minus 4. Just like that, we have answered 1.1.1. Let's go ahead and take a look at 1.1.2. We're supposed to solve for x correct to 2 decimal places. We know that we are going to use the quadratic formula. We have 3x squared minus 2x being equals to 6. So 3x squared minus 2x minus 6 should be equals to 0. We just write in the equation in our standard format. X is equals to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Let's go ahead and substitute. B is the coefficient of x, which is minus 2, plus or minus b squared, again minus 2 squared, minus 4ac. A is 3 and c is minus 6. C is the constant and a is the coefficient of x squared. We are supposed to divide everything by 2a. We know that a is 3. So x will be equals to minus multiplied by minus 2. That will be plus 2. Plus or minus the square root of b squared minus 4ac. 4 plus 72 is 76. Everything divided by 6. So x is equals to 1.79 or x is equals to minus 1.12. When you substitute these values of x back into your equation, it's going to be satisfied. You're going to get 6 on both sides. 1.1.3, we have the square root of 2x plus 1 being equals to x minus 1. This question is a very basic question. It is always there in the final exam. We're going to square both sides. We're going to have the square root of 2x plus 1 squared being equals to x minus 1 squared. So on the left hand side, we're going to have 2x plus 1. The square root and 2 just cancels out, being equals to x minus 1 squared. X multiplied by x, that is x squared. X multiplied by minus 1, that is minus x. You multiply that by 2, you're going to get minus 2x. And then minus 1 multiplied by minus 1, that is plus 1. We're going to have x squared minus 4x. If you take 2x to the right hand side, it's going to be minus 2x, which is minus 4x. And then 1 minus 1 is 0. So x squared minus 4x is equals to 0. We can take x as a common factor. We're going to have x minus 4 being equals to 0. In this case, it's either x is equals to 0 or x is equals to 4. Let's do 1.1.4. So in 1.1.4, we have x squared minus 3 being greater than 2x. So if we take 2x to the left hand side, we're going to get x squared minus 2x minus 3 being greater than 0. Let's go ahead and find our critical values. X squared minus 2x minus 3 is equals to 0. We're not changing the equation. We just want to find our critical values. After finding our critical values, we will take care of the inequality. Now we just want to find our critical values. So how can we factorize this? Two numbers of which when we multiply we get minus 3 and when we add we get minus 2. That is minus 3 and plus 1. So x minus 3, x plus 1 is equals to 0. So x is equals to 3 or x is equals to minus 1. These are our critical values. So if you've been watching my other videos, you know the two possible answers we're going to have here is either x lies between -1 and 3, or x is greater than 3, or x is less than -1. These are the two possible solutions we can possibly have. We are going to test and see which one between these two is correct. So let's go ahead and test this first one. How can we test that one? We take a number between -1 and 3 and see if our equation is going to be satisfied. If our inequality, not equation, right? So let's take 1 as it is between -1 and 3. We are substituting it into the equation we started with, the inequality I meant. So we're going to have x squared minus 3 being greater than 2x. If we substitute 1, we're going to have 1 squared minus 3 being greater than 2 multiplied by 1. So 1 squared 1 minus 3 minus 2 is greater than 2. Obviously, this is not correct. So it tells us that our answer is not between -1 and 3, but rather x is greater than 3 or x is less than 1. So this is our correct answer. This is wrong. Right, that is one way of solving an inequality. Anyway, stories 1.2. Let's do 1.2 and 1.3 on a separate video. Let's solve for x and y simultaneously. I have x plus 2 being equals to 2y. And I have 1 divided by x plus 1 divided by y being equals to 1. Well, on this equation, I can make x the subject of the formula. I'm going to have x being equals to 2y minus 2. Let's take our attention to the other equation. If we multiply the left-hand side by x and multiply the right-hand side by x, we're going to have 1 plus x divided by y being equals to x. In place of x, we can go ahead and substitute 2y minus 2. We're going to have 1 plus 2y minus 2, everything divided by y being equals to 2y minus 2. So we're going to have 1 plus 2y divided by y minus 2 divided by y being equals to 2y minus 2. 1 plus y and y cancels out, we are left with 2. Minus 2y being equals to 2y minus 2. We can multiply the left-hand side and the right-hand side by y. If we do that, we're going to get y plus 2y minus 2. Y and y are going to cancel out, being equals to 2y squared minus 2y. We're going to have 2y squared minus 5y plus 2 being equals to 0. If we factorize this, we can do that without using the quadratic formula. We're going to have minus 2 and minus 1. If we multiply out, we shall get 2y squared minus 5y plus 2. This is all equals to 0. So y can be equals to 1 divided by 2, or y can be equals to 2. If y is equals to 1 divided by 2, then what will be the value of x? X will be equals to 2 multiplied by a half minus 2. 2 multiplied by a half, that is 1, minus 2, we get minus 1. And then if y is equals to 2, then x will be equals to 2 multiplied by 2 minus 2. This is just equals to 2. Well, let's play around with those values and see if they check out. Y is equals to a half and x is equals to minus 1. We're going to have minus 1 plus 2. This is obviously 1. And then 2 multiplied by a half is also equals to 1. So our equation is satisfied when you use those two values. Let's now check when y is equals to 2 and x is equals to 2. Let's use the other equation. When that is the case, we're going to have 1 divided by 2 plus 1 divided by 2, which is 1, which is equals to 1, like we are supposed to show. So that checks out. Let's go ahead and do 1.3. 1.3 given 2 to the power m plus 1 plus 2 to the power m being equals to 3 to the power n plus 2 minus 3 to the power n, where m and n are integers. Where m and n are integers, determine the value of m plus n. I think I've solved a similar question before. Let's go ahead and give it a try. Well, I want to get rid of this 2 to the power m plus 1. I know fully well that it is equals to 2 to the power m multiplied by 2 to the power 1. Because if we multiply in numbers of the same basis, we can add the exponents. So 2 to the power m plus 1 is just 2 to the power m multiplied by 2 to the power 1 plus 2 to the power m. Let me just try out the same idea on the right hand side. So I'm going to have 3 to the power n multiplied by 3 to the power 2 minus 3 to the power n. On the left hand side, I'm going to take 2 to the power m as a common factor. I'm going to have 2 to the power 1 plus 1 being equals to, I'm taking 3 to the power n as a common factor on the right hand side. So 3 to the power n, and then I'm going to be left with 3 to the power 2 minus 1. 3 to the power 2 is 9 minus 1 is 8, right? But we can write 8 as 2 to the power 3. So let's run with that idea. We're going to have 2 to the power m multiplied by 2 to the power 1, that's 2, plus 1 is 3. So we have 2 to the power m multiplied by 3, being equals to 3 to the power n multiplied by 8, which is just 2 to the power 3. Let's not forget that we have 1 here. If m is equals to 3 and n is equals to 1, the left hand side and the right hand side are going to be equals to each other. So we can say that m is equals to 3 and n is equals to 1. When this is the case, the left hand side is indeed equals to the right hand side. I think they're supposed to be equals to 24 or something. So what will be m plus 1 when m is equals to 3 and n is equals to 1? That is 3 plus 1, which is just equals to 4. Let's see if we can write down the general term of this series. So we have 3 plus 6 plus 12, our geometric series. The general term of a geometric series, it is given by Tn is equals to ar to the power n minus 1. A is the first term. The first term in our case is 3. R is T2 divided by T1 or T3 divided by T2. We just divide the two terms that are next to each other. So here, if we divide T2 by T1, we're going to have 6 divided by 3, which is equals to 2. So we have A, we have R. Tn will be equals to A, which is 3, R, which is equals to 2 to the power n minus 1. So this is the general term of this series. Let's move to 3.1.2. So in 3.1.2, we're supposed to calculate the value of k such that this sum is equals to 98,301. Okay, let's go ahead and find the terms of our series. So the first term, T1, will be equals to 3 divided by 2, 2 to the power p. P is starting at 1, right? So when p is equals to 1, we're going to have 2 divided by 2, so T1 is equals to 3. And then T2, we're going to have 3 divided by 2, and then 2 to the power 2. 2 to the power 2 is 4, so we're going to have 4 multiplied by 3, which is 12. 12 divided by 2 is 6, so that is T2. And then T3 is equals to 3 divided by 2, 2 to the power 3. 2 to the power 3 is 8, so we have 8 multiplied by 3, 8, 16, 24. So we have 24 divided by 2, which is equals to 12. So it seems like we just have 3 plus 6 plus 9. We're supposed to find the value of k, for which this sum is equals to 98,301. 1. How can we possibly do that? We have a formula for the sum of a geometric series, while a finite and an infinite. In our case, we're going to have the sum being equals to a multiplied by r to the power n minus 1 divided by r minus 1. You cannot use sum to infinity is equals to a divided by 1 minus r in this case, because r is not between minus 1 and 1. Okay, so what is the value of n for which we're going to have a sum of 98,301? Let's find out. A is the first term, which is 3. R is the common ratio, which is 2. So 2 to the power n minus 1, everything divided by r minus 1. So that is 2 minus 1, which is just 1. Okay, so we're going to have 2 to the power n minus 1 being equals to 98,301 divided by 3. Okay, let me put that in my calculator real quick. I'm getting 2 to the power n minus 1 being equals to 32,767. If I take minus 1 to the right hand side, I'm going to get 2 to the power n being equals to 32,768. I don't know whether I can write this number with a base of 2 or not, but it is just going to waste my time trying to figure that out. I'm just going to go ahead and take log on both sides. If I do that, I'm going to get n log of 2 being equals to log of 32,768. So I can just divide both sides by log of 2, right? So 32,768, everything divided by log of 2. So let me go ahead and put that in my calculator and see what I have. So 32,768 divided by log of 2. So n is equals to 15. The value of k is supposed to be equals to 15, such that we have a sum of 98,301. N is equals to k minus p plus 1. N is 15. K, p is 1 plus 1. So it's easy to see that 15 is equals to k. Right, so that is 3.1.2. Let's go ahead and do the last question, 3.2. So in 3.2, let's hear the stories. A geometric sequence and an arithmetic sequence have the same first term. Okay, so let's have arithmetic and have geometric. Okay, they have the same first term. So we have a and a. T1 is equals to a. This a is the same, right? And then the common ratio of the geometric series is 1 divided by 3. So common ratio r is equals to 1 divided by 3. And then the difference on the arithmetic is equals to 3. And then the stories carry on. The sum of 22 terms of the arithmetic sequence is 734, more than the sum to infinity of the geometric sequence. Okay, let's make sense of that mathematically. The sum of the 22 terms of an arithmetic sequence is 734, more than the sum to infinity of the geometric. So, okay, S22 should be equals to S infinity plus 734. That is how I'm interpreting the question. Okay, but what is sum on an arithmetic series or sequence, whatsoever we're dealing with here? We have n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. And then the sum to infinity is a divided by 1 minus r plus 734. Okay, let's go ahead and substitute. N is equals to 22. So we're going to have 22 divided by 2 multiplied by 2a. So we have 2a is a. That's what we're interested in actually. And then plus n minus 1. So 22 minus 1 multiplied by d, which is 3. Okay. This is equals to a divided by 1 minus 1 divided by 3 plus 734. Okay, we have to solve this now. So we're going to have 11 multiplied by 2a. Then 22 minus 1 is 21. So we're going to have 21 multiplied by 3. Is that 63? Okay, so we have plus 63 minus... Okay, no, that's it. 21 multiplied by 3. 2a plus 63. This is equals to a divided by... What is 1 minus 1 divided by 3? That is 2 divided by 3. Okay, so if we say 1 divided by 2 divided by 3, we're going to get... Instead of writing a there, let's instead write 3 divided by 2a plus 734. Okay, let's multiply out on the left hand side. We're going to get 22a plus 63 multiplied by 11. That is 693, being equals to 3 divided by 2a plus 734. Let's take the a's to the left hand side and the constants to the right hand side. Okay, the a's to the left. So we have 22a minus 3 divided by 2a being equals to 734 minus 693. So what is 22 minus 3 divided by 2? We have 41 divided by 2a being equals to 734 minus 693, which is 41. Okay, so a is equals to, I have 41 divided by 41 divided by 2. A is equals to 2. Did you get the same answer? Just let me know in the comments. Write down the equation of the asymptote of f, that is 4.1. We have f of x being equals to 2 to the power x minus 4. We're looking for the asymptote of this function. Let me show you something. In order for f of x to be equals to minus 4, we would need 2 to the power of x to be equals to 0. And that is actually impossible. We get very close to 0, but we never touch 0. So that tells us that our asymptote is that y is equals to minus 4, because our graph cannot touch y is equals to minus 4, because 2 to the power x will never be equals to 0. We just get close to 0, but we never actually get there. 4.2. That is where the idea of a limit actually comes in. Anyway, stories. Let's determine the coordinates of b. We are told that a and... What's happening? We're told that a and b are y and x intercepts respectively. So a is the y-intercept, so x equals to 0, and we have some y. And b is the x-intercept, and y is equals to 0. F of x is equals to 2 to the power x minus 4. If we substitute the coordinates of b, x and 0, in attempt to find x, we're going to have 0 being equals to 2 to the power of x minus 4. If we take minus 4 to the left hand side, we're going to have 2 to the power x being equals to 4. But we can write 4 as 2 to the power of 2. It is easy to see that x is equals to 2. So the coordinates of b, we have 2 and 0. Let's go ahead and do 4.3. In 4.3, we're supposed to determine the equation of k, a straight line passing through a and b in the form k of x is equals to. Well, if it is a straight line, then this is mx plus c. We need the gradient. After finding the gradient, we can substitute b or a to find c. How can we find the gradient? We need 2 points. Well, for b, we know that we have 2 and 0. If we can find the coordinates of a, we're going to be able to determine the gradient of k of x. So the coordinates of a, we have x is equals to 0 and it's a unknown y value. If we substitute that into f of x is equals to 2 to the power x minus 4. We're going to get y being equals to 2 to the power 0 minus 4. Any number to the power 0 is 1, so we have 1 minus 4, which is minus 3. So the coordinates of a, we have 0 and minus 3. If we go ahead and find the gradient, we'll get y2 minus y1 divided by x2 minus x1. We have b and a. If we take a as our second point, we're going to have minus 3 minus 0. The y value of a minus the y value of b divided by 0 minus 2. So this is just equals to 3 divided by 2. So that is the gradient of k of x. We can say that k of x is equals to 3 divided by 2x plus c. Let's substitute either a or b to find the value of c. If we substitute b, b is 2 and 0. We're going to have 0 being equals to 3 divided by 2 multiplied by 2 plus c. 2 and 2 cancels out. We have 2 being equals to 3 plus c. It is obvious c is equals to minus 3. So we can conclude and say that k of x is equals to 3 divided by 2x minus 3. Is this equation true? Is it correct? Let's find out. Let's substitute the x value of a. If we substitute 0, we're going to get 3 divided by 2 multiplied by 0 minus 3. So this is just equals to minus 3. Well, it seems like it works out. Let's go ahead and do 4.4. So in 4.4, we want to calculate the vertical distance between k and f at x is equals to 1. The vertical distance between k and f. Right, we are looking for the distance, not the displacement. Okay, so if we're looking for the displacement, it would matter whether we're seeing f of x minus k of x, but if it is the distance, it doesn't matter. Even if we get a negative value, we would just quote it as a positive value because distance is not a vector, but it is a scalar. Anyway, let's carry on. But if you connect a and b, you should be able to see that k of x is above f of x between a and b, and that is where x is equals to 1 lies. X is equals to 1 is between a and b, so the distance will be equals to k of x minus f of x. Well, k of 1 minus f of 1, because that's the point we're interested in. So k of x, we're gonna have 3 divided by 2. We are interested at x is equals to 1 minus 3 minus f of x, 2 to the power 1 minus 4. So 3 divided by 2 multiplied by 1, that is 3 divided by 2, which is 1.5. So we have 1.5 minus 3, that should be minus 1.5. So we have minus 1.5. Minus 2 to the power 1. 2 to the power 1 is 2. 2 minus 4, it is minus 2. So we have minus 1.5 plus 2, which will be plus 0.5 units. So that is the distance between k of x and f of x. Let's move to 5.5. In 5.5, not 5.5, but 4.5. We're supposed to write down the equation of g if it is given that g of x is equals to f of x plus 4. So g of x will be equals to, what is f of x? This is 2 to the power x minus 4 plus 4. Minus 4 plus 4, so g of x is just equals to 2 to the power x. Right, and 4.6, let's write down the domain of g inverse. So the range of g of x is equals to the domain of g of x. So what is the range of g of x if g of x is equals to 2 to the power x? Well, the range y is an element of 0 to infinity. It cannot touch 0, but it cannot touch infinity also. We know that for sure. So this is the range of g of x. So the domain of g inverse x will be an element of 0 to infinity. That's how it works. That's all we have to do. And 4.7, we actually need to find the equation of g inverse. G of x is equals to 2 to the power x. To find the inverse, you swap x and y and make y the subject to the formula. In this case, we're going to have x being equals to 2 to the power y. If we want to bring y down, we have to take a log on both sides. If we do that, we're going to have y a log of 2. That is a log law. You are allowed to do that. What you want to do at this point is to divide both sides by log of 2. We're going to have y being equals to log of x divided by log of 2. What is log of x divided by log of 2? That is log of x base 2. If you get 18 out of 18 in this question, then your math is really good. Let me show you why I say that. So we have the graphs of f and g that are drawn below. A point of intersection of f and g is B, the turning point of f. The graph f has x-intercepts -3 and x is equals to 5 and the y-intercept at C. The first question, 5.1, let's write down the coordinates of the turning point of f. Well, we are told that f of x is equals to -1 divided by 2 multiplied by x minus 1 squared plus 8. When your equation is written in this format, 1 will be the x value of your turning point and 8 will be the y value of your turning point. So the coordinates of B, the turning point of f, is x is equals to 1 and y is equals to 8. That's pretty much basic. It's not a difficult question whatsoever. Let's go ahead and do 5.2. In 5.2, we're looking for the x coordinate, for the coordinates of C, not the x coordinate. C is the y-intercept of f. So y-intercept, I know x is equals to 0. If I go ahead and substitute x is equals to 0 into f of x, I'm going to have -1 divided by 2 multiplied by 0 minus 1 squared plus 8. Let's take a look at this. 0 minus 1, that is -1. You square that, you get 1. So we have -1 divided by 2 plus 8, which should be 7.5. 7.5, I think we can write it as 13 divided by 2 instead. So the coordinates of C, we have an x value of 0 and a y value of 13 divided by 2. 13 divided by 2 is 6.5 and not 7.5. So we're supposed to have 15 divided by 2 instead. Let's go ahead and do 5.3. Calculate the value of D. D is a variable on g of x. Well, we know that g of x is equals to D divided by x. We are told that g of x and f of x, they touch at B. So B is a point on g of x. But lucky for us, we've already determined the coordinates of B. The x value is 1 and the y value is 8. If we substitute that into g of x, of which we can do with no issues whatsoever because B lies on g of x and f of x, we're going to have 8 in place of the y value being equals to D divided by x, which is 1. It should be easy to see now that D is equals to 8. So basically, g of x is equals to 8 divided by x. That is 5.3. Seems like all is going well. 5.1, 5.2, 5.3. Let's see what happens in 5.4. In 5.4, we're looking for the range of g. G of x is equals to 8 divided by x. Well, if x is positive, we're going to have all positive y values, obviously, except from 0 and infinity. In order for g of x to be equals to 0, we need x to be equals to 0. And we cannot divide by 0. So basically, g of x cannot touch 0. So we know that 0 to infinity is part of our solution. And then let's look at when x is negative. When x is negative, we run from minus infinity to 0. We cannot touch 0 even. The range of g of x is just minus infinity to 0 and 0 to plus infinity. So that is the range of g of x. It's not really hard to see. The only thing you need to realize is that g of x cannot be equals to 0. So basically, you can say that y is an element of real numbers, but y is not equal to 0. 5.5, we're looking for the values of x for which f of x multiplied by g of x is less or equals to 0. Right, f of x is our parabola, and g of x is 8 divided by x. So let's talk about this 8 divided by x first. When x is positive, 8 divided by x is positive. When x is negative, 8 divided by x is negative. That is very important to point out. I'm going to show you why. But we know fully well that in our solution, we cannot include x equals to 0. Whatever interval we can have, it must not include x is equals to 0, because g of x is not defined at that point. We need to be aware of that. Well, let's go to our graph. Let me show you something. Okay, so between minus 3 and 5, f of x is positive. Between minus 3 and 5. And then minus 3, minus 4, minus 5 going to minus infinity, f of x is negative. And then from positive 5, positive 6, going on and on, f of x is negative. That is important to point out. Okay, let's look at minus 3 to minus infinity and see what is happening. So from minus 3 to minus infinity, both f of x and g of x are negative. As you can clearly see here, both g of x and f of x will be negative. If we multiply two negative numbers, then our answer is going to be greater than 0. So minus 3 to minus infinity is not our solution, because f of x multiplied by g of x will be greater than 0. Let's look at minus 3 to x is equals to 0. From minus 3 to x is equals to 0, f of x is positive and g of x is negative. So minus 3 to positive 0 is part of our solution. We can include minus 3 because both f of x and g of x are defined, but we exclude 0 because g of x is not defined at 0. So that is part of our solution. Now let's look at 0 and 5. Between 0 and 5, f of x is positive, as you can clearly see, but g of x is also positive. So that cannot be part of our solution. If we multiply those two functions between 0 and 5, our answer is going to be greater than 0, and that's not what we're interested in. Let's look at x is equals to 5 to positive infinity. X is equals to 5 to positive infinity. F of x is going to be negative, and g of x is going to be positive. Negative multiplied by positive, that is negative, and it will satisfy our inequality. So what are we saying? We're saying that we are also interested in the part where x is between 5 and infinity, but including 5. We can include 5 because both f of x and g of x are defined. So yes, this is our solution for 5.5. Between minus 3 and 0, f of x multiplied by g of x will be less or equals to 0. Same is true between 5 and infinity. That is our answer to 5.5. Let's go ahead and do 5.6. 5.6 and 5.7, that's where things start getting a bit interesting, but there ain't nothing to it but to do it. Let's take a look. Calculate the values of k such that h of x is equals to minus 2x plus k will not intersect the graph of g. Right, we have h of x being equals to minus 2x plus k, and g of x being equals to 8 divided by x. So we're looking for the values of k for which h of x will not be equals to g of x. Well, let's say you've never seen a problem like this before. What are you most likely to do? You're most likely to start by saying h of x is equals to g of x. If we were to substitute here, we will get minus 2x plus k being equals to 8 divided by x. Obviously, this x is a disturbance, so let's multiply out by x. If we do that, we get minus 2x squared plus xk being equals to 8. X and x will cancel out, right? Writing this in standard format, we're going to have 2x squared minus xk minus 8 being equals to 0. I think most people will probably get to this point, but now you're stuck. You don't know how to carry on anymore. Well, as you can see, this is a quadratic equation. We're looking for values of k for which the two graphs won't touch. So basically, what you have to do, you have to find the discriminant of this quadratic equation. Let me show you how. The discriminant is equals to b squared minus 4ac. You know that your quadratic equation is not going to have solutions if the discriminant is less than 0. There's no square root of a negative number. So if the discriminant is less than 0, then your quadratic equation is not going to have any solution. So we are interested in the values of k for which this quadratic equation is not going to have any real solutions. And in doing that, we have essentially solved our problem. We have the values of k for which the two functions h of x and g of x will not intersect. Right, that is a lot to digest. So maybe you need to rewind a bit and listen to it again. But anyway, stories. The discriminant is equals to b squared minus 4ac. We're interested in the case where b squared minus 4ac will be less than 0. Well, in our case, b is minus k, right? The coefficient of x. So we have minus k squared minus 4ac. C is A, not C. A is 2 and C is minus 8, less than 0. So minus k squared, that will be k squared. There's a mistake I'm making. I'm only realizing it now. This is supposed to be plus 8 and not minus 8. When I take 8 to the left hand side, it is going to be minus 8. And then when I multiply out by minus 1, then it will be plus 8. So this is actually plus 8 and not minus 8. Right, so we're going to have k squared minus 64 being less than 0. If we take 64 to the other side, we're going to have k squared being less than 64. Let's go ahead and find our CV critical values. So k squared is equals to 64, k is equals to 8, or k is equals to minus 8. The solution to this inequality, we have k being between minus 8 and positive 8. It has to be greater than minus 8 but less than positive 8. So these are the values of k for which h of x will not intersect g. 5.6. Let's do the last one. Let's do 5.7. So in 5.7, h is a tangent to g at r, a point on a point in the first quadrant. Calculate t such that y is equals to f of x plus t intersect g at r. So we are interested at f of x plus t is equals to g of x. We want to find the value of t for which f of x plus t is equals to g of x. How can we possibly do that? Let's look at the information we have. We are told that h is a tangent to g at r. H of x is equals to minus 2x plus k. This is the gradient of h of x. So basically, we have the gradient of h of x at r, right? It is equals to minus 2 because h of x is the tangent to g at r. So what are we saying? We're saying that if you derivate g of x and equate to minus 2, you can find the x value at r, the point we're interested in. Let me show you how. So we want to derivate g of x. Let's start by saying g of x. So g of x is equals to 8 divided by x. But this is the same as saying 8 multiplied by x to the minus 1, right? So if we go ahead and derivate this using the power rule, we're going to get minus 8 multiplied by x to the minus 2. But we know the gradient at r. The gradient at r is minus 2. So now we're interested in finding the x value at r. So we're going to say minus 8. We can take x to the minus 2 back to the denominator, which will be x to the power 2. If we cross multiply here, we get 2x squared is equals to 8. We divided both sides by minus 1 at the same time. Right. So 2x squared is equals to 8. Dividing both sides by 2, x squared is equals to 4. X is equals to 2. So the x value at r is 2. But we can take that a step forward. We can also find the y value at r because we have the equation g of x. So the y value at r, we're going to have 8 divided by x, which happens to be 2. So that is 4. The coordinates of r, we have 2 and 4. We are almost done. That is what you actually have to figure out. As soon as you figure that out, then it becomes extremely simple. Right, let me show you why I'm saying that. We have y being equals to f of x plus t. But y at r is 4. So we're going to have 4 being equals to f of x. X is 2. So that will be minus 1 divided by 2, x minus 1. So that is 2 minus 1 squared plus 8 plus t. So 4 is going to be equals to 2 minus 1 squared, that is 1. So we just have minus 1 divided by 2 plus 8 plus t. So 4 is equals to, what is minus 1 divided by 2 plus 8? That is 7.5, which is just 15 divided by 2. So we have 15 divided by 2 plus t. T should be equals to 4 minus 15 divided by 2, which is just equals to minus 7 divided by 2. Determine f prime of x from first principles. If 7.1 f of x is equals to minus 4x squared. From the power rule, we know fully well that f prime of x should be equals to minus 8x using the power rule. But we're supposed to use first principles. So we're going to have f of x being equals to the limit as h tends to 0 of f of x plus h minus f of x, everything divided by h. So let's go ahead and determine f of x plus h separately. If we do that, we're going to have f of x plus h being equals to minus 4. In place of x, we are substituting x plus h. So we're going to have x plus h squared. This will be equals to minus 4 multiplied by x squared plus 2xh plus h squared. This is just equals to minus 4x squared minus 8xh minus 4h squared. Right, so that is f of x plus h. If we include also minus f of x, we can say that f of x plus h minus f of x is equals to minus 4x squared minus 8xh minus 4h squared minus f of x, which is minus 4x squared. So as you can see, minus 4x squared minus 4x squared, that is 0. So f of x plus h minus f of x is just equals to minus 8xh minus 4h squared. If we substitute it back into our equation, we're going to have f prime of x being equals to the limit as h tends to 0 of minus 8xh minus 4h squared, everything divided by h. If we take h as a common factor on the denominator, on the numerator I meant, we're going to have h multiplied by minus 8x minus 4h, everything divided by h. If h and h cancels out and we let h turn into 0, we're going to have minus 8x minus 0 basically. So f prime of x is just equals to minus 8x, which is the same solution we get to using the power rule. So yeah, we are convinced that 7.1, we have it correct, all the 5 marks. Let's move to 7.2.1. 7.2.1, we're supposed to determine f prime of x if f of x is equals to 2x to the 3 minus 3x. Out of 2 marks, we're just going to use the power rule. The power rule states that if we have some g of x, which is equals to ax to the b, then g prime of x will just be equals to b multiplied by ax to the b minus 1. If we go ahead and apply this same idea on f of x, we're going to have 3 multiplied by 2 to the power multiplied by x to the power 3 minus 1 minus 1 multiplied by 3 x to the power 1 minus 1. So f prime of x will be equals to 3 multiplied by 2, that is 6. So we have 6x squared minus 1 multiplied by 3, that is 3. X to the power 1 minus 1 is x to the power 0. Any number to the power 0 is 1. So our answer here is 6x squared minus 3. Let's see, does it make sense? 6x squared minus... Yeah, I think it checks out. So that is 7.2.1. Let's take a look at 7.2.2. Well, a question like 7.2.2, 7.2.1, and 7.1, you know they're going to be there in your final exam. The variables, the numbers are going to change, but the technique is the same. Well, let's look at 7.2.2. So we have dx and 7 multiplied by the square root of x squared. We have that 3 up there plus 2x to the minus 5. Right, so let's just rewrite this nicely in the following way. We're going to have 7x to the power 2 divided by 3. Yes, we can bring this 3 right here. We are allowed to do that. Plus 2x to the minus 5. It seems like everything is in standard form now. We can go ahead and derivate. So we're going to have 2 divided by 3 multiplied by 7x to the power 2 divided by 3 minus 1 plus minus 5 multiplied by 2x to the minus 5 minus 1. So what is 2 divided by 3 multiplied by 7? That is 14 divided by 3, x to the power 2 divided by 3 minus 1. That is minus 1 divided by 3. And then minus 5 multiplied by 2 minus 10, x to the minus 6. Well, let me check if I'm not making any mistake. 2 minus 5 minus 10, x to the minus 6. So this is correct. Let's check this one. Okay, 7x to the 2 divided by 3. this is fine, and then I multiply 7 by 2 divided by 3. I think all is well. I think all is well. We can move ahead and do 7.3. You can let me know if all is not well in the comments. So 7.3 is very similar to 2.2.3, where we're supposed to find the values of n for which a quadratic pattern is increasing. So here we're supposed to find the values of x for which the tangent to minus 2x to the 3 plus x will have a positive gradient. Right, so f of x is equals to minus 2x to the 3 plus 8x. The equation of the tangent is given by f prime of x will be equals to. So we're just derivating using the power rule. We're going to have minus 6x squared plus 8. So we're looking for values of x for which minus 6x squared plus 8 is greater than 0, right? Because that's where the gradient will be positive. This equation is the equation of the gradient of f of x. Right, so let's go ahead and solve that. We're going to have minus 6x squared being greater than minus 8. We're taking plus 8 to the right-hand side. We're going to divide both sides by negative 1. If we divide by negative 1, the sign of the inequality changes, right? So we're going to have 6x squared being less than 8. Dividing both sides by 6, we're going to get x squared being less than 4 divided by 3. We can go ahead and find our critical values. We're going to have x being equals to the square root of 4 divided by 3 plus, or x being equals to minus the square root of 4 divided by 3. But if you go ahead and evaluate, x is between minus the square root of 4 divided by 3 and plus the square root of 4 divided by 3. If you substitute any value between minus the square root of 4 divided by 3 and plus the square root of 4 divided by 3, indeed, the gradient is going to be positive. So this is the answer to 7.3. When x is between these two values, the gradient is positive, which makes sense because our the function of the gradient of f of x is going to look something like this. For only a few values of x will this function be greater than 0. Determine the coordinates of the turning points of f. Okay, so we have f of x, which is equals to minus x to the power 3 plus 6x squared minus 9x plus 4. In order to find the coordinates of the turning points, we need to derivate and equate to 0. That is because the gradient at the turning point is equals to 0. So if we derivate f of x and equate to 0, then we're going to find the x values at the turning points, substitute them into f of x, and find the corresponding y value. So let's go ahead and do that. F prime of x will be equals to, so we just simply apply in the power rule here. We're going to get minus 3x squared plus 12x minus 9. Right, and then minus 3x squared plus 12x minus 9 is equals to 0. So if we divide throughout by minus 1, we're going to have 3x squared minus 12x plus 9 being equals to 0. Let's go ahead and factorize this. On the first bracket, you're going to have 3x. On the second bracket, we're going to have x. We want minus 12x as the middle term and minus 9 as the constant. The way of doing that is if we have 3x minus 9 and x minus 1 being equals to 0. Here we're going to have x is equals to 3, and on the other side we're going to have x is equals to 1. Obviously 3x minus 9 is equals to 0, 3x is equals to 9. We divide both sides by 3, x is equals to 3. So these are the x value of the turning points. But we are looking for the coordinates, so we need to substitute these x values into f of x. So we're going to have f of 3 being equals to minus 3 to the power 3 plus 6 multiplied by 3 squared minus 9 multiplied by 3 plus 4. This is equals to 4. And then on the other hand, f of 1 will be equals to minus 1 to the power 3 plus 6 multiplied by 1 squared minus 9 multiplied by 1 plus 4. This is equals to 0. So the turning points, we have 3 and 4, 0 and, not 0 and 1, but 1 and 0. So these two are our turning points. Right, let's go ahead and do 8.2. In 8.2, we're supposed to draw the graph of f and clearly label all the intercepts with the axes and any turning points. So turning points, we have our turning points, so that is covered. Let's now look at the intercept. Do we have the x-intercept? Yes, we do. This turning point also serves as an x-intercept because y is equals to 0. So the x-intercept, we have that covered. Okay, let's go ahead and look at the y-intercept. Do we have the y-intercept? We don't, but we can go ahead and find it. The y-intercept, so f of 0, we know that y-intercept x is equals to 0. We're going to have minus 0 to the power 3 plus 6 multiplied by 0 squared minus 9 multiplied by 0 plus 4. So f of 0 is just equals to 4. So yes, we have the turning points and we have all the intercepts. We can go ahead and sketch our cubic function. Let's go ahead and do that. So let me just put my axis here and see what I can do. My y-axis and my x-axis. Okay, I have 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. And then going up, we have 1, 2, 3, 4. Going down, minus 1, minus 2, minus 3, minus 4. Right, let's go ahead and plot our coordinates. Okay, let's take a look at the turning points. We have 3 and 4, 1 and 0. So when x is equals to 3, y is equals to 4. We have a turning point right there. And then when x is equals to 1, y is equals to 0. We have a turning point right here. Okay, the x-intercept, let's take a look at the x-intercept right here when y is equals to 0, x is equals to 1. So that turning point is also serving as an x-intercept. Okay, and then the y-intercept when x is 0, y is 4. So we have a y-intercept. Okay, there's something I'm forgetting. There's another intercept here at x is equals to 4. Let me show you how that is coming about. F of x is also equals to, look at this equation here that they have factorized for us. X minus 1 squared multiplied by minus x plus 4. So obviously we have minus x plus 4 being equals to 0. So x is equals to 4. This is the other x-intercept that we have. Okay, let's carry on and do the equation that follows. We are done sketching that graph. 8.3. Use the graph to determine the values of k for which minus x to the power 3 plus 6x squared minus 9x plus 4 is equals to k. We'll have 3 real and unequal roots. A very basic equation. So we have f of x is equals to k. So f of x minus k is equals to 0. So we want to shift f of x such that we're going to have 3 real and unequal roots. Right now, by the roots, we mean the x-intercepts, by the way. Right now, we have 2 unequal roots. X is equals to 1 and x is equals to 4. Let me show you something. If we shift f of x downwards, then we're going to have 3 real and unequal roots. But then if you keep shifting it downwards, then we're going to have a problem. You can see that at this point we have 2 unequal and real roots. So we need to shift our function downwards. We need to shift our graph downwards. But then we need the value of k to be between 0 and 4. If k exceeds 4, 4 is the local maximum. If k exceeds 4, then we will no longer have 3 unequal and real roots. And if k is less than 0, then we are actually shifting our graph upwards. Our condition is not going to be satisfied. So we need k to be between 0 and 4. Let's move to 8.4. So in 8.4, the line g of x is equals to ax plus b is the tangent to f at the point of inflection of f. Determine the equation of g. So point of inflection. We can easily find the x value at the point of inflection. So let's do that first. So f of x is equals to minus x to the 3 plus 6x squared minus 9x plus 4. If we derivate this, f prime of x is equals to minus 3x squared plus 12x minus 9. So if you want to find the x value at the point of inflection, you have to derivate again and equate it to 0. If we do that, we're going to have f prime of x being equals to the second derivative, minus 6x plus 12. We need to equate this to 0. So we're going to have minus 6x plus 12 being equals to 0. Minus 6x is equals to minus 12. X is equals to 2. This is the x value at the point of inflection. We can substitute this x value into f of x and find the corresponding y value at the point of inflection. If we do that, we're going to have f of 2 being equals to 2 minus 1 squared multiplied by minus 2 plus 4. This is equals to, so we have 1 squared multiplied by 2, so we have 2. This is the point of inflection. The x value is 2 and the y value is 2. But this very x value, we can substitute it into f prime of x to find the gradient at that point. Because if we have the gradient at that point and g of x is the tangent at that point, then we're going to have the gradient of the tangent. Okay, so f prime of 2 will be equals to, what do we have? Minus 3 2 squared plus 12 multiplied by 2 minus 9. This is equals to 3. So g of x is equals to 3x plus b. We have the gradient at our point of inflection. In order to find b, we need to substitute our point of inflection of coordinates 2 and 2. If we do that, we're going to have 2 being equals to 3 multiplied by 2 plus b. b will be equals to 2 minus 6, which is equals to minus 4. So g of x will be equals to 3x minus 4. This is the equation of g of x. The last question, 8.5, is quite easy to compute. We're looking for the value of theta, the acute angle formed between g and the x-axis in the first quadrant. The angle between g of x and the x-axis is the angle of inclination. And we know fully well that if we say tan of theta is equals to the gradient, it shouldn't be hard to find theta. So theta will be equals to tan inverse of 3. If you put that in your calculator, 71.57 degrees. Question 9 is usually difficult, but I think this one was bearable. Let's take a look at it. The diagram below represents a printed poster. A rectangle ABCD is the part on which the text is printed. The shaded area ABCD is 432 centimeters squared, and AD is equals to x centimeters. So we have AD being equals to x centimeters. Let's carry on. ABCD is 4 centimeters from the left and right edges of the page, and 3 centimeters from the top and bottom of the page. All right, and the first question, 9.1, we're supposed to show that the total area of the page is given by A is equals to 3,456 divided by x plus 6x plus 480. Let's go ahead and make sense of that. We have a rectangle, so the area of a rectangle is the length multiplied by the breadth. So let's go ahead and see if we can have the length and the breadth in terms of x and multiply in order to find the total area. Well, we know that AD is x centimeters. So from A to D, we have x centimeters. From D to the edge, we have 4 centimeters. And then from A to the edge, we have 4 centimeters. It means that from this edge to this edge, let's call that our length. Our length is equals to 4 plus x plus 4, right? So the length will be 8 plus x. We have 4 from here to here, and then from here to here we have x, and then from here to here we have 4. So that length is just 4 plus x plus 4, which is 8 plus x. That is the length. Let's go ahead and take a look at the breadth. Let me just erase this first and see what we have. From here to here we have 3 centimeters, obviously, and then from here to here we have 3 centimeters. We just need the length from this point up to here. How can we do that? We have the area of the shaded area. It is said to be 432 centimeters. So we have 432. The formula for that area would be AD multiplied by DC. This is equals to 432. But we know that AD is x. So we have DC being equals to 432 divided by x, basically. That is why we are given the area of ABCD. Right. So here we have 432 divided by x. So the length of the poster is 432 divided by x plus 3 plus 3. These 3 right here from D to the poster, and this 3 from C to the poster, plus 432 divided by x, which is the length of DC. So the breadth will be equals to 432x plus 6. This is the length and this is the breadth. So we can say that the area of our poster in terms of x will be equals to the length, which is 8 plus x multiplied by the breadth, which is 432 divided by x plus 6. So we just have to multiply these two brackets. 8 multiplied by 432 is 3,456 divided by x. And then 8 multiplied by 6. What is 8 multiplied by 6? That is 48. So we have plus 48. Now we multiply x by 432. We're going to get 432x. There's this x on the denominator, so they will cancel out. Plus 6x. This will be equals to 3,456 divided by x plus 48. 48 plus 432, that is 480. So we're going to have 6x plus 480. This is exactly what we are required to show. Let's go ahead and move to 9.2. In 9.2, we're supposed to determine the value of x for which the total area will be a minimum. You know fully well, this is almost always the case. We're going to derivate the equation in 9.1 and equate to 0. Let's do that first, and we're going to talk about why we're doing that. So a of x is equals to 3,456 divided by x plus 6x plus 418. But we can rewrite this, right? A of x will be equals to 3,456 x to the minus 1. That is the same as divided by x plus 6x plus 418. Let's go ahead and derivate this using the power rule. We're going to have a prime of x being equals to minus 3,456 multiplied by x to the minus 2 plus 6. Let's now equate to 0. 3,000 minus 3,456 x to the minus 2 plus 6 is equals to 0. X to the minus 2 is problematic, so let's write it as minus 3,456 divided by x squared plus 6x being equals to 0. We can multiply both sides by x squared. If we do that, we're going to get 6x squared minus 3,456 being equals to 0. So 6x squared is equals to 3,456. So x squared will be equals to 3,456 divided by 6. If we take square roots on both sides, we're going to have x being equals to 24 or x being equals to minus 24. So tell me, between x is equals to 24 and x is equals to minus 24, which one corresponds to the maximum and which one corresponds to the minimum? Let me know in the comment section. We have events A and B that are independent. The probability of A is equals to 1 divided by 3, and the probability of B is equals to 3 divided by 4. The first question, 10.1.1, we're looking for the probability of A and B. The probability of A and B will be equals to the probability of A multiplied by the probability of B. A and B are independent events. So we're going to have 1 divided by 3, the probability of A, multiplied by 3 divided by 4, the probability of B, being equals to 3 divided by 12, which is just 1 divided by 4. This is the probability of A and B, 10.1.1. Let's take a look at 10.1.2. There's a bit of swag here in 10.1.2. The question is saying, what is the probability of at least one event occurring, at least one event taking place? That is just a fancy way of saying what is the probability of A or B, right? So the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B, right? 10.1.1 was just setting us up to answer 10.1.2. So the probability of A or B will be equals to the probability of A, which is 1 divided by 3, plus the probability of B, which is 3 divided by 4, minus the probability of A and B, which is 1 divided by 4. This is equals to 5 divided by 6. 10.1.2. Let's move ahead and do 10.2. Quite an interesting one, but I feel like we have solved this problem before in some of the videos we have done previously. Let's take a look at it. The probability that it will snow on the mountains in June is 5%. When it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 72%. We're going to make sense of that. No need to worry. Let's just read through our statement and see what information we have. If it does not snow on the mountains, the probability that the minimum temperature will drop below 0 degrees Celsius is 35%. Right, and then the first question, 10.2.1, represent the given information on a tree diagram. Clearly indicate the probabilities associated with each branch. 10.2.1 is probably setting us up to do 10.2.2. But let's just go ahead and solve this problem. We have 10.2.1. We're supposed to represent this in a tree diagram. Well, let's start. So it's either it is going to snow or it is not going to snow. So snow and not snow. One of those two has to happen. It's either it is snowing or it is not. It cannot be in between or both at the same time. So what is the probability that it will snow? Is 5%, right? We are given that. So we have 5 divided by 100. That is the probability that it will snow. If the probability that it will snow is 5 divided by 100, the probability that it will not snow is 95 divided by 100. I hope that makes sense. And then let's carry on. If it snows, then the temperature can be less than 0, but it is also possible that it can snow and the temperature be greater than 0. So what is the probability that when it snows, the temperature is less than 0? Let's go ahead and find out. You can see clearly here that if it snows, then the probability is 72% that the temperature is going to be less than 0. So we have 72 divided by 100. Okay, and then if the probability that it will snow and the temperature being less than 0 is 72%, then the probability that it snows and the temperature be greater than 0 will be 100 minus 72, which is 28. So we have 28 divided by 100 being the probability that it will snow and the temperature will be greater than 0. Right, let's move on to not snow and figure out what we have here. So t less than 0, t greater than 0. Okay, so if it does not snow, what is the probability that the temperature will go below 0 degrees Celsius? It is given to us as 35%. So if it does not snow, there's a probability that the temperature will be less than 0, which is 35 divided by 100. Obviously, for t greater than 0, we're going to have 65. Yes, 65 plus 35, 100. So we have 65 divided by 100 being the probability that it will not snow and the temperature will be greater than 0, which makes sense. Right, so this is the information we have represented on a tree diagram. 10.2.1. How many marks? 3 marks. Yeah, it's a lot of work. I don't know why it's 3 marks, but anyway, stories. Let's carry on and do 10.2.2. So in 10.2, calculate the probability that the temperature in central South Africa will not drop below 0 degrees Celsius in June 2024. We have to use our tree diagram. We want the probability that it will not drop below 0. Okay, let's go ahead. We can see clearly that here it is not dropping below 0 because the temperature is greater than 0. And even here it's not dropping below 0 because the temperature is greater than 0. So we have to add those two probabilities. How do we do that? Okay, let me show you. So first of all, if it snows, the probability that the temperature will be greater than 0 is 28 divided by 100. And if it does not snow, the probability that the temperature is greater than 0 is 65 divided by 100. That is what we have to figure out. In order to find the probability of the temperature being greater than 0 when it has snowed, we have to multiply the probability of snow and the corresponding probability of the temperature being greater than 0. So we have 5 divided by 100 multiplied by 28 divided by 100. When we go up the branches, we multiply, and when we go down, we add. This is equals to 7 divided by 500. On the other hand, we're going to have 95 divided by 100 multiplied by 65 divided by 100, which is equals to 247 divided by 400. Makes sense, right? If it does not snow, the temperature will probably be greater than 0. All these probabilities make sense. So the answer, we're supposed to add these two. We're going to have 7 divided by 500 plus 247 divided by 400. This is equals to 0.6315. That is the probability that the temperature will not drop below 0 degrees Celsius in June 2024. Right. Let's move ahead and do 10.3. Quite an interesting question. I did spend a lot of time on this question, trying to see if I'm missing something. But anyway, we have 10 learners that randomly sit in a line, one behind the other. So in how many different ways can 10 learners stand in the line? Oh, they stand, they don't sit on a line. If we have 10 learners and they're sitting randomly, then we have 10 factorial ways of which they can sit. Right, that is quite an easy one. 1 mark in the bag, 10.3.2. Calculate the probability that there will be 5 learners between the 2 youngest learners in the line. That is where things start to get interesting. Okay, let's go ahead and have our, I don't want to say our seats, but yeah, let's go ahead and have 10 spaces. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've always used this method, and I'm always going to use it. Okay, so we want to find the probability that 5 learners will sit in between the 2 youngest learners. So let's say, for instance, we have y1 being the first youngest learner, and then in between we have 1, 2, 3, 4, 5. The 5 learners that are supposed to be between the 2 youngest. And then after that, we have y2, right? The second youngest learner. And after that, we're going to have 6, 7, 8, right? So in total, we have 10 learners. So let's go ahead and make sense of this. The probability is going to be equals to some number divided by the sample space, which is 10 factorial. So let's go ahead and figure that out. So we can have y1 first or y2 first. So there's 2 factorial ways in which y1 and y2 can arrange themselves between themselves. Okay, so this is 2 factorial. It's either y1 starts or y2 starts. So there's 2 factorial ways of doing that. Multiplied by, now let's take a look at the 5 learners in between y1 and y2. Well, they can arrange themselves in 5 factorial ways, right? Okay, so now that we have taken care of y1 and y2 and the 5 learners in between, we need these 7 learners to move as a unit because they need to be in between those 2 youngest learners. So if they're moving as a unit, then we have 1, 2, 3, 4 ways we can play around with the 7 learners and the 3 that are not in between. So that is another 4 factorial ways we can arrange the 3 learners that are left out with the 7 learners, the 2 that sandwich the 5 in between them. So the probability is just 2 factorial. So we have 2 factorial. Let me just put that in my calculator. Multiplied by 5 factorial, multiplied by 4 factorial, divided by 10 factorial. This is equals to 1 divided by 630. Yes. Let me know in the comments if there is something I'm missing.